Today you're going to learn how to do your last mole conversion, but before I teach you how to do the math for this last conversion, you're going to see these letters quite often in the question, so you need to understand what these letters are telling you. STP, if you ever see that in the question, it stands for standard temperature and pressure. So scientists have chosen a temperature and a pressure to be standard, and instead of saying the numbers in the experiment or the question, they can just say that it happened at STP. So for now, these are the actual temperatures and pressures that it is. So it's 0 degrees Celsius is standard temperature, which is the freezing point of water. It's the same as 32 degrees Fahrenheit. And then standard pressure is 1 atmosphere. ATM stands for atmospheres. And we're going to actually do a lot more with these numbers in our next unit. For this chapter, you won't actually have to use these numbers. But just as a side note, they are in your reference table, so you won't have to memorize these, and they're pretty easily accessible if you have that reference packet. But for this chapter, you just need to recognize that when you see STP, it means you can do this type of mole conversion that I'm about to show you. So this has to do with Avogadro's hypothesis, which says that equal volumes of gases at the same temperature and pressure contain equal numbers of particles. So basically what he's saying is that if you hold a lot of things constant for a gas, then other things will be constant as well. And so what he was able to figure out is that if you always have standard pressure, you always have standard pressure, and you have 1 mole, he figured out that no matter what kind of gas you had, it always occupied 22.4 liters. And so now we have this new conversion where 1 mole is equal to 22.4 liters. However, this is a very specific conversion. So in my AP class, I often have a lot of students try to use this when they can't, because it has to have both of these conditions to use it. In this class, for honors chemistry, all of the questions will be at these conditions, so you can use this for this class. But just keep in mind that if you take upper level chemistry classes, that you have to make sure it says that it's a gas, and it has to be at STP in order for this conversion to actually work. All right, let's do the first question. So we're going to convert moles into liters. And notice that it has STP in the question. What that means is that you're allowed to use that conversion. 22.4 liters is equal to 1 mole. And also, by the way, 22.4, that number is in your reference packet, so you don't need to memorize that. So start with what you're given, top left corner. So moles are going to go up here. Just like before, you're going to take this unit and pull it down diagonal to cancel. You're going to put liters on top because that's what we're looking for, and then you're going to plug in this conversion. So again, 1 goes with the mole, 22.4 goes with the liters. And then you just do the math, multiply across the top, divide by the bottom, and you should get about 121 liters. Let's try another one. This time we're going to go backwards. Actually, it's this moles to liters again. So we're going to do 5.4 moles of CH4, turn it into liters. So let's set it up, starting with what we're given. Bring moles down diagonal. Liters goes on top because that's what we're looking for. Plug it in, and guess what we get? Same answer. So the point here I'm trying to make is that it doesn't matter what chemical you have. Notice in our last question it was helium. This question is CH4, which is methane. So it doesn't matter what gas you have. It's always going to be 22.4 liters per mole as long as you have a gas at STP. Now, it won't always be the same number because we won't always start with 5.4, but you can always do this conversion if these two conditions are met. All right, let's go backwards. So now we have liters to moles. Again, start with what you're given on the top left corner. This unit is going to come down diagonal. Moles is going to go on top this time. So you can't memorize where to put them. You have to set them up to cancel this unit here and to end up with what you want on the top. And then just like before, wherever you write mole, that's where the 1 goes, and then 22.4 goes with liters. So this time you're going to divide by the liters in order to get moles. All right, so we have now done these 3 calculations, and what I would suggest for you to do is to pause this and take a minute and draw this picture in your notes. So this is showing you all of the 3 calculations you've done now. We can turn moles into particles, but you won't see the word particle. You'll see either molecule, formula unit, or atoms, depending on which type of particle it is. You can turn it into grams. There's not a number for this. This is where you have to use the periodic table and add up the grams per mole. Or you can do liters if it's a gas at STP. Notice that all 3 of these turns it into 1 mole. So for all 3 of these calculations, where you write mole, you're going to put the 1. Where you write the other unit, that's where you'll put either 22.4, Avogadro's number, or the grams from the periodic table. One other side note is that they might not say liters in the question. They might say, what is the volume? You have to know that volume is measured in liters. so you know what to calculate. So keep in mind that these two go together. Same thing down here. They might not say what is the grams, they might say what is the mass. You have to know that mass is measured in grams. All right, so let's look at this question. It says we have 5 liters of CO2. How many grams would that be? So we can't go directly from liters to grams, but we can go to moles, and then once we have moles, then we can go to grams. So this is going to be a 2-step problem, but you can do it all in the same fence. You don't have to break it into multiple fences. So let me walk through what we have here. Always start with what you're given on the top left corner. Then you're going to take this unit and bring it down diagonal. And because it's a gas at STP, we can use this conversion factor to turn it into moles. Notice that the 1 goes with the mole and the 22.4 goes with liters. So if we stopped it right here and calculated it, we would end up with moles of CO2. But they didn't say what was the moles, they said how many grams. So now we're going to take moles and bring that diagonal. So notice that whatever you want to cancel needs to come down diagonal. We're going to put grams on top. Whenever you see grams, you need to think periodic table. So this number right here, 44, came from adding up 1 carbon and 2 oxygens. Carbon is about 12 grams per mole in the periodic table. Each oxygen is about 16, so that's 32 plus 12. That's where we're getting that number 44 here. And then you just do the math. So 5 times 44 and then divided by 22.4. Notice that liters cancels, moles cancels, and the only thing that doesn't cancel is grams. And so that's your final unit, which is what they were asking you for. Feel free to pause these if you need some more time to write down the problems. All right, let's do another one. This one is asking for molecules, and that's a type of particle, but they're giving us grams. So the first thing to notice is that we don't have moles. They didn't give us moles, they didn't ask us for moles, so usually that's going to be your first step, is to get it into moles. Then once we have moles, then we can turn it into molecules. So let's set up the fence, starting with grams. Always start with what you're given on the top left corner. Take that and bring it down diagonal. And whenever you see grams, you need to think periodic table. So oxygen is about 16, each hydrogen is about 1, so that's where I got this 18 from. Notice that mole is going to go here, and we put a 1. So far, all we have learned about the mole is that it gets a 1. It won't always, but I'll teach you once it's not going to get a 1. Up until now, so far, it's always gotten a 1. Now we're going to take this mole and bring it down diagonal because we want to cancel that and turn it into molecules. Be careful how you abbreviate molecules. You don't want to put MOL because then it's confusing whether you have moles or molecules. So this is how I like to abbreviate molecules. And when you do Avogadro's number, that number goes with either formula units, molecules, or atoms, and the 1 goes with the mole. So set your units up first so the moles cancel, then plug in your numbers. Make sure that the 1 goes with the mole. Let's check and see if our units cancel. We have grams canceling grams, moles here cancels moles here, and we're left with molecules. So you're going to do 60 times Avogadro's number divided by 18. And that is it for today.